Okay, trig identities. A trigonometric identity is an equation that is true for all values of the variable for which the expression on both sides of the equation are defined. The basic identities you must be familiar with are tan x equals sine x over cos x, cotan x equals cosine x over sine x. There's the Pythagorean identity, sine squared x plus cos squared x equals 1. And I know you're wondering where these are coming from, and I'm going to prove them to you in just a second, okay? And then there's the reciprocal identities, which you're already familiar with. Cosecant x is 1 over sine x, secant x is 1 over cos x, cotan x is 1 over tan x. So we can use an angle on the coordinate axes to prove the above identities, right? Do you recall, if this is y, this is r, this is x, cosine x equals x over r, sine x equals y over r, right, opposite over hypotenuse, and tan x equals y over x. So, using these definitions, for example, the quotient identity tan x equals sine x over cos x, I'm going to prove using these definitions, okay? So left side equals tan x, and you know that that is equal to, tan x is equal to opposite over adjacent, y over x. Right side equals sine x over cos x. You know that sine x is y over r, cos x is x over r, and that is equal to, multiply by the reciprocal when you divide by a fraction, and that is equal to y over x. Can you see the left side equals the right side? Right? We end up, that's why tan x equals sine x over cos x, because as you can see, when we use these variables to prove it, the left side equals the right side. And if this is just the reciprocal, right? Cotan x is just the reciprocal of tan x, so that's just going to be the reciprocal of sine x over cos x, which is cos x over sine x. Okay, let's prove a Pythagorean identity. Okay, you are given sine squared x plus cos squared x is equal to 1. Well, the left side is equal to y squared over r squared, and cosine squared x is x squared over r squared, and that is equal to x squared plus y squared over r squared. And you know, by the Pythagorean theorem, x squared plus y squared equals r squared. So you have r squared over r squared. That equals 1. Right side equals 1. So your left side equals your right side. Okay, if we were to look at another Pythagorean identity, 1 plus tan squared x equals secant squared x, well, left side equals 1 plus tan squared x, and that is equal to, well, I'm going to do it in a different way actually. Hold it a sec. Oh, just wait. Don't worry, don't panic. Please don't panic on me. Here. I'm going to just show you that if we use the first one from sine squared x plus cos squared x equals 1, if I were to divide everything by cos squared x, cos squared x, cos squared x over cos squared x, if I were to just divide everything by cos squared x, can you see that this is just tan squared x plus 1 equals secant squared x? See how you can derive this one from this one? That's all I did. You can derive this one from the sine squared x plus cos squared x. If I just go through and divide everything by cos squared x, I'm not really changing anything. This is tan squared x, that is 1, and this is secant squared x. Similarly for this guy, sine squared x plus cos squared x equals 1. If I divide everything by sine squared x, that's the same as 1 plus cotan squared x equals cosecant squared x. And so you can derive these two identities from the first one. That's all I did. So let's look at a number of proving trig identities. That's the objective of this lesson, is for you to learn how to prove trig identities. So what's some general rules of thumb? Work with the left side and right side separately. You cannot assume the equation is true. So you separate the left side from the right side. Work from the complex to the simple. In many cases, it helps to convert everything to sine and cos. You might have to work both sides. Is everything okay back there? Okay. Use algebraic manipulation along with the basic identities to prove the formulas. Okay. So let's look at this. Now, when you're proving, do not use x, y, and r. You're going to use the trig identities. You won't get any marks on the test. If it says prove the following trig identities, you won't get any marks. Use trig identities. Okay. So, when we prove, we work with the left side and right side separately. So let's start. The most complex one is this guy. Left side equals 1 minus cos squared x over sine x. What do you think 1 minus cos squared x equals? Yeah. So you know this is true. You're working with this. So if you subtract cos squared x, sine squared x equals 1 minus cos squared x. So we know that this equals sine squared x over sine x. And what does sine squared x divided by sine x equal? Sine x, right? Right side equals sine x. Left side equals right side. Yep. Well, the x, that's sine of an angle. The x's don't divide out. Yeah. Right? They're together. Yeah, you can't just divide them out. Okay, so let's look at this guy. Again, work with the most complex to the simple. You can't get any more simpler than 1, so we're going to work with the left side. So you have left side equals 1 minus cos squared x times 1 plus cotan squared x. So you know from the previous example, 1 minus cos squared x is equal to sine squared x. And what does 1 plus cotan squared x equal? Cosecant squared x. And you know that this is the reciprocal of sine squared x. You have sine squared x times 1 over sine squared x. Right? And these divide out. Sure, sorry. And that equals 1. So right side equals 1. Left side equals right side. Any questions? Am I going too fast? A bit? Okay, I'll slow down. So this is an interesting one. The left side is sine theta over 1 plus cos theta. The right side is 1 minus cos theta over sine theta. So one thing we could do, so I'm just sort of showing you some tricks of the trade. Okay? Because the right-hand side has a 1 minus cos theta, that gives me a hint as to how to prove this. So I'm going to just write that left side down first. I'm going to multiply this by 1 minus cos theta over 1 minus cos theta, because this in effect is multiplying by 1, so I'm not changing anything when I multiply by 1. And I'm multiplying by 1 minus cos theta over 1 minus cos theta just because I see a 1 minus cos theta on the right hand side, so that gives me a hint as to what to multiply it by. So this is equal to sine theta times 1 minus cos theta all over, well, 1 times 1 is 1, minus cos theta plus cos theta minus cos squared theta. So that's going to fall out, right? So right now I have sine theta times 1 minus cosine theta all over 1 minus cos squared theta. And what does 1 minus cos squared theta equal? It equals, from here, 1 minus cos squared theta equals sine squared theta. So that equals sine theta times 1 minus cos theta all over sine squared theta. And sine theta goes into sine squared theta sine theta times. So we're left with 1 minus cos theta over sine theta. So right side equals 1 minus cos theta over sine theta. Left side equals right side. So we did it. We proved it. Is everything okay back there? Okay. I want to show you one where we convert everything to sine and cos. Okay. Do you notice how everything on the left-hand side is in terms of sine and cos? So why don't we change everything on the right-hand side to things in terms of sine and cos? So right side equals tan x over 1 plus tan x. Well, you know tan x is equal to sine x over cos x all over 1 plus sine x over cos x. So I just used the fact that tan x equals sine x over cos x. How can I add these two guys together? What do I need? A common denominator. So what can I change 1 to? Yeah. So this is sine x over cos x, right? Cos x over cos x plus sine x over cos x. Right? So now I have a common denominator. So this is going to be sine x over cos x, what was on the top before, all over cos x plus sine x all over cos x. When we divide by a fraction, we can multiply by the reciprocal. So this is going to be sine x over cos x times cos x over cos x plus sine x. That divides out, and we're left with sine x over cos x plus sine x. No, not when there's a plus sign. So left side equals sine x over cos x plus sine x, and therefore left side equals right side. So I want you guys to try E and F, and I'm going to walk around and help you. I think you have enough knowledge to do 1 E, F, G. Oh, H is a tricky one. I'm going to do H with you because H is a tricky one, and I'm going to then walk around and help you out on some of these. There's a trick here. Okay, out of the left side and the right side, which one is the most complicated? Yeah, the left. So let's start with the left. Now this is the trick. Cos squared x plus sine squared x equals 1. That's a Pythagorean identity, right? So we're going to write that in terms of cos squared x and sine squared x. So this is going to be sine squared x plus 2 sine x cos x plus cos squared x all over sine x plus cos x. Ooh. So I took that one and I replaced it with sine squared x plus cos squared x. This is tricky. Could anyone want to try to factor this for me? Do you see how we could factor this? A binomial times a binomial. Right. Sine x plus cos x times sine x plus cos x. Right? That times that equals that. Sine x cos x plus cos x sine x equals, like when you can check, you can FOIL and check. So this binomial times this binomial equals our numerator. Now what can we do? Do you see? Yeah, divide it out and we get sine x plus cos x. So right side equals sine x plus cos x. Left side equals right side. You have all the tools you need to try this out. Start with part E. And I'll take attendance and I'll walk around and I'll help.